The Attolab physics group in Lund is part of Lund University, which is located in the southern part of Sweden. The research we do in our group aims to study the electron motion inside atoms and molecules, and since its motion is so very fast, we need extremely short laser pulses to do this, so-called attosecond pulses. Attosecond pulses were first produced and characterized 10 years ago, and since then it has been possible to initiate and also study the electron motion. This is really great. To have access to the timescales on which the electron moves means that a totally new world opens up, and it's truly fascinating to be part of this.
Yeah, it's really innovative field, and the field that basically open kind of new avenues for probing ultra-fast processes in the matter.
To get a feeling for how short an attosecond pulse is, a comparison is usually useful. If you compare 1 attosecond to a second, it's the same as 1 second relates to twice the age of the universe. This is the timescale electrons move, and this is the timescale we need to access if we want to see them move. Our vision at Lund University is to understand, explain and improve the world around us. To live up to this vision, our group developed techniques to see and capture and eventually also control electron motion in real time.
You want to study atoms or molecules on a very, very short time scale. And these are time scales which are far from anything what we can think of. But it's nevertheless very fascinating to understand that and to try to get an insight into the physics behind.
We use attosecond pulses and tailor laser light to look into the microcosm, with the hope to see electrons as they start to move inside and between atoms and molecules. That's what we dream about. To tailor light fields and control the electron motion, we use 3 different laser systems and different experimental setups. The workhorse in this respect is the kilohertz laser system with 6 millijoule pulses and a duration of 20 femtoseconds. We use this to produce attosecond pulse trains. The use of pulse train has almost become a trademark here in Lund. It means that you have access to the attosecond time domain while still being able to do spectroscopy. The experiments here are all based on interferometry between a pump beam and an attosecond pulse train and an IR probe beam. We use this setup to study various fundamental properties of atoms, but also molecules and sometimes nanostructures. The detected signal is almost always obtained in an electron spectrometer. It can be a magnetic bottle spectrometer, where we measure the integrated electron spectra, or a velocity map imaging spectrometer, where we also measure the angular distribution of the electrons. In some experiments, where more than one electron is ionized at the time, we need to measure both electrons in coincidence. The second system uses a much more powerful laser that operates at 10 Hz. With this system, we generate intense attosecond pulses, aiming at XUV pump, XUV probe experiments, but still with attosecond resolution. The aim here is in particular molecular imaging, but also nonlinear effects and seeding of free electron lasers. While the 10 Hz system delivers very high intensities at rather low rep rate, the newest edition works the other way around. It's a high repetition rate system producing many pulses per second, but with rather modest intensity. This system will be used in experiments where we only want to ionize 1 electron per pulse, but still get high average signal. Experiments in nanostructures where we use a photoemission electron microscope as a detector is a typical example of this.
The group is really international. We have people mostly from Europe, but also from South America and Asia.
I would say that this is a perfect environment to do science and to do research.
Half of Lund, you could always say, the university basically, half of Lund are students.
Lund is really special because of this internationality, and everything is around the university here. So there are plenty of people from around the world and you can meet on the street and share their ideas.